All right, everybody, let's go. 624. What sequence makes them the same? Similar figures and transformations. Okay, so far in this chapter, you have investigated transformations and similar figures. Recall that reflections, okay, all right, remember these. Man, you've got to feel comfortable with this. Reflections, rotations, and translations are all special cases of transformations that are called rigid transformations. And again, remember, rigid means they do not change in size, they just move, okay? Today, we'll investigate how to use transformations to show that two figures are similar. Now, similar is different, okay? And we've talked a lot about similar today in class. We're going to continue to talk about similarities or what makes shapes similar here as we go. All right, now, the work we're doing today is on a handout, okay? This handout is going to be used for the video and then for class tomorrow. So right now, I'm going to leave this and go to the handout and kind of work the rest of it with the handout. So this is what the handout should look like. So please get the handout if you don't have it printed out. But this is really going to help you out with what we're doing today and tomorrow, okay? We're going to do 76 and 77 today. Tomorrow, you'll do the rest of it, okay? So here we go. 676. Look at the graph. Look at these shapes right here, A and B, okay? Do you think these figures are similar? Why or why not? Okay, I'd like you to take a minute and pause the video and answer that question. Do you think they're similar? Why or why not? Okay, you could make some arguments for things, but if you remember, similar means three things. Number one, they're the same general shape. Number two, all the angles are congruent. In other words, they match. The angles do not change when we move these shapes. And number three, they can be the same size. They can be bigger or smaller, but basically they're multiplied by the same scale factor. So are these two shapes similar? Yes, they are similar. They are the same general shape. With congruent angles and a scale factor of 2. Because if you notice, all these sides, like this side here, matches up with this side, and this is 2, this is 4, this is 4, this is 8. So all the sides seem to have been multiplied by 2, okay? So the scale factor is 2. All right, now what you're going to do is question B. Describe a sequence of transformations, reflections, rotations, translations, and dilations. Remember, dilation is multiplying something by something to make it bigger or smaller to change figure A to B. So we're starting with A, and you're moving A to B, okay? So tell me what you'd have to do to go from A to B. And again, you can do it on your worksheet there, but I want you to try to make a series of things that would go from A to B. And then I'm going to show you what I think would work best for this, okay? All right, so pause the video, write down your work, and then we'll discuss it. Unpause it when you're done. All right, so here's the thing. I will admit, right now, how it currently is on that graph, it's kind of a pain. It's hard to do some of the work that might be necessary to make this happen. So I actually have it here, and this is the exact same thing, but I just want to show you a slightly different way. It's a little bit bigger here. So these are exactly the same locations, same places, okay? Here is my advice. Some of you maybe try to do your rotations and translations first, like, hey, I'm gonna rotate the shape, rotate it, and then I'm going to move it over, and then I'm going to multiply it. The problem being that when you multiply, it moves the shape, okay? So my advice whenever doing this work is whenever going from a bigger to smaller, smaller to bigger, whenever you're doing dilations, do them first. Because if you do them first, they will do all that growing and changing coordinates, and then you can worry about rotating and reflecting and translating to get it to where it needs to be, okay? So as we mentioned before, the scale factor here is 2, right? So you could say, I'm going to multiply by 2 first. So step number 1, dilate by 2, which means everything multiplies by 2. Now this right here is -2, -2. Point -2, -2 changes to point -4, -4. So this point is going to end up down here. And then this point here is point -2, -4. So -2, -4 multiplied by 2 gives you -4, -8. So -4, -8 would be down here, okay? Then this point, let's go at this point here. This is 1, 2, 3, 4, 5, 6, -2. So -6, -2. And let's go ahead and finish off here. -6, -4. So when I multiply all these by 2, I get -12, -4, and -12, -8. Now, here's the problem. I'm already here. Even though I made it bigger, I'm still going to run out of room. 1, 2, 3, 4, 10, 11, 12 would be somewhere over here, okay? And then the same thing over here would be somewhere over there. So I end up with my shape all the way off the grid. But see, dilating by 2 didn't just make it twice as big, or the sides twice as big, but it also moved them down here, okay? Now that I do this, now all I have to do is get it to the place I want to go, okay? So multiplying everything by 2 first moves it there. I'm going to erase this here because I need the space here. My next step, what I would do next, is I would rotate it. And I want to rotate it this way, right? I want to rotate, like stand it up here, okay? So I want to rotate it, and I think I only have to rotate it 90 degrees. Oh, by the way, what direction? If I go this way, this would be clockwise, right? And I only really want to go from here to where this line goes standing straight up, so that would be 90 degrees. So step number 2, let's go to a different color. Step number 2 would be to rotate clockwise, or well, let's put the whole thing here. Rotate 90 degrees clockwise. Now I do need to say about what point I need to rotate it at. And I think rotating it on this point, like putting my pencil here and turning it from here, would be the best way to do that. And if I rotate it, that would be about point, that's -4, -4. Okay? About point -4, -4. So now, when I rotate that, this all moves up here, and you could use your tracing paper to do this, but it would end up looking, oh, didn't mean to do that. When I rotate it, it would end up going this. And my shape would end up rotating like that when I rotate it 90 degrees clockwise. And then I can do the final step and see how easy, if I do the dilation first, it makes things go a lot easier. Now I can do the final step to move it from this point to, remember, this point, because I want to match up the sides. This point does not go with this point here. This point in green coordinates with this point over here. It corresponds with it. So I need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the right. So do you remember what I do that? So I need to translate. Move 10 to the right. I do x plus 10, and then I need to move it up 2. And what would move it up to? Y plus 2. And if I do that, that's going to take this whole shape right here. Ready? Move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then up to, ta-da, gets it to where I need to go. So here is my choice of how to do it. Now, you did not have to do it this way. You could have done it a bunch of different ways, but that's just one of the ways to do it, okay? You need to start feeling comfortable doing that process and getting more and more fluent and just comfortable with doing that work, okay? All right, then, how does your sequence of transformations prove that the figures are similar? Well, how does it prove that they're similar? Remember, similar has to be the same shape, just it can be bigger or smaller, but you can't change the angles. Well, what did we do? We did we dilated. And so dilation, rotation, and last thing we did is translation. Do not change the shape except for the size. So we did dilation, but the rotation and the translation we did are rigid transformations. So the dilation was the only thing that changed the size of the shape, and we use the same scale factor for all the sides. Therefore, if all we do is reflection, rotation, translation, that doesn't change the size, and then we multiply everything by the same number, it makes sure the shapes are similar. Okay? Hopefully that makes sense. Now, last problem we're doing on the video today, problem 677. Figures that are congruent are the same shape and the same size. Now, this is confusing, so please be careful. In fact, please circle this. Congruent, same shape and the same size. Congruent means that they are the identical shape. They do not get bigger. They do not get smaller. Okay? You can also say that they have a scale factor of 1. Scale factor of 1. By the way, if you have two shapes that are congruent, are they similar? Are they? Okay. Yes, they are similar, because similar means they can get bigger or smaller. But remember what we said. Just because they say can doesn't mean they don't, or that they have to. So they could be the same size. So which transformations can you use to show that two figures are congruent? Okay, what transformations could you use that would keep the shape congruent? All right. What are they? Well, they are rigid transformations. Rigid transformations, which are rotation, reflection, and dilation. Nope. Oh, I'm sorry. Whew, I was wrong there. Reflection, rotation, not dilation, and translation. Whew. So all three of these are the rigid transformations. If you just do the rigid transformations, the new shape is going to be congruent. They're going to be exactly the same. They're not bigger. They're not smaller. They're not a different shape. They're the same thing. And which transformation or transformations will cause figures that are not congruent but similar? And that would be dilation. Dilation, if you do dilation, you still multiply both sides by the same scale factor, so they are similar, but they're not congruent because you're making them bigger or smaller. Okay? Cool? All right, that is it for today. Hopefully that makes sense to you. We will continue this worksheet tomorrow in class. Please make sure you've got these notes written down. If you did not get anything, please go back and fix it, okay? Because I will be expecting to see those notes tomorrow in class, okay? All right, have a great day. I'll see you then. Oh, I need to stop sharing here.